Absorption, reflection, and transmission of light. In this lesson, we're talking about light rays, geometric optics, reflection, transmission and refraction, absorption, categories of light, and then lasers. Light rays. A luminous object like a candle radiates light in all directions. You can see that from this diagram here on the right-hand side. You can see how our light rays are going in every direction. Right, left, top, bottom, etc. To show how light rays emit from a source, we use our light rays that we have right here. So those are light rays that we draw to show that light emitting from a source. A light ray is simply a line with an arrow representing the direction and a straight path of the light ray. Light rays. Because a candle radiates light in all directions, there should be an infinite number of light rays. However, we only draw a few of them to simplify things and to represent what's going on. A laser, however, emits light rays all in the same direction. So you can see how our candle emits it in every direction. Our laser emits it in one direction only. So you can see our example here in our laser, you're going to get your parallel beams of light that are going in one direction only. Some key terms. Geometric optics is the use of light rays to determine how light behaves when it strikes an object. For example, is it reflected back? Does it go through the object, etc. An incident light ray is a light emitted from a source that strikes an object. For example, light from the sun striking the earth. Geometric optics. So when light interacts with matter, three things can happen. Number one, reflection. Light can bounce off the substance. So think of a mirror. So light ray coming in, hits the mirror, and bounces off. Number two, transmission, refraction. Light changes direction in a new substance. Think of a pond. When light comes in, it's going to bend. We'll have a lot more on that later. And number three, absorption. Light energy is converted to another form of energy in the material. So think of light rays hitting a black shirt. The light rays hit the black shirt, and they're all absorbed into the black shirt, creating heat. So what types of materials reflect, transmit, and absorb light the best? So what I'd like you to do is pause the video, and on the following slide, you're going to see sections for you to write down light rays that are reflected, transmitted, and absorbed. And I want you to write those down. So here they are here. So pick one for absorb light, pick one for transmit light, and an object that reflects light. So pause the video and do that now. Now the reality is that most objects reflect, transmit, and absorb light in certain amounts. For instance, on a glass window, 30% of light is reflected, 5% is absorbed, and 65% is transmitted. This is why you can see reflection in a transparent window, but you can still see what's on the other side. It's also why glass gets hot after a while if it's exposed to enough sun. Light. Matter can also be classified into three categories depending on how it behaves when light strikes it. All material can either be classified as transparent, translucent, or opaque. A transparent material is a material that lets light pass through easily when light strikes it. Objects behind are easily seen. For instance, clear glass. We got this ice bubble here, and we have the dragonfly wings right there. An object can be translucent, so when light strikes it, some light passes through. Now, a translucent object doesn't allow you to see the objects clearly on the other side, but light can still pass through. Some of it can, anyhow. So an example of that is a frosted glass. And you can see that here, like ice on a windshield in winter, or a frosted glass that you put in the freezer. So in the example of the frosted glass on the right-hand side, you'll notice that we can't see what's on the other side, but it's also not a solid material that you can't see through at all. Some light is getting through, just not enough for us to see what's on the other side. And lastly, our objects can be opaque. So something like a cardboard box, a brick wall, a cat. These are all opaque objects. An opaque object is an object that does not allow light to pass through. Since light is either absorbed or reflected, it's not possible to see the objects behind. Lasers. Lasers is actually an acronym. LASERS stands for Light Amplification by Stimulated Emission of Radiation. The first one was built in 1960 by Theodore H. Mailman. We have many applications today. Since lasers can be focused to a microscopic dot of extremely high energy density, we can use it as an effective cutting and cauterizing instrument in medicine and industry. We can use it to measure distances. Communications via fiber optics, barcode scanners, and various other kind of weapons can also utilize lasers. Incandescent bulbs versus lasers. Incandescent bulbs emit light of many energy levels, so we get many colors being produced. Lasers produce only one electromagnetic wave, so only get one color out of it. So you're going to get a blue laser, a red laser, a purple laser, but you're not going to get a laser that spans multiple colors, whereas a light bulb is going to emit white light, which is comprised of all the different colors. Incandescent bulbs shine light in all directions and spread out, as you can see in our top diagram here. Whereas a laser, all the electromagnetic waves travel in the same direction in a very narrow beam. This makes lasers very intense, and it's also why you should never shine a laser directly in your eye, because it can damage it due to the high intensity of the electromagnetic radiation being emitted from it. Lasers. A high-energy laser is so intense and so concentrated that it can be used to burn a hole through steel. Also, they can be used to measure the distance from the Earth to the Moon with an accuracy of 3 centimeters. So very useful and very intense. So I want you to finish this video by watching these two videos, which have an interesting look at how lasers function and why they can be so useful. And that concludes our lesson on lasers, absorption, and transmission.